Hey guys, it's Coach Tapman, and today we are going to be talking about screws as a simple machine. So, what is a screw? A screw is an inclined plane wrapped around a central shaft, but the inclined plane also comes to a sharp edge around the outside, which acts as a wedge as it pushes into the fastened material, and the shaft and helix also form a wedge in the form of the point. Well, that was a lot of words, so let's look at an example of what we're talking about. As we can see, we have the shaft of this screw wrapped with an inclined plane comes to a wedge at its edge. Okay, well that's very useful. Well, let's look at how we calculate the ideal mechanical advantage for something like that. Because it's fairly straightforward, because it seems like it would be complicated given the definition. To calculate our ideal mechanical advantage, we're actually going to take the 2 pi times the length or the radius outward to where the rotational force is going to be applied, or the force contributing to the rotation. And so in this scenario, we would actually have this L radius. We would be interested in this L distance, so it would be 2 pi L over P, and P is just your pitch. And so think of pitch as the number of threads in a given length of space. It is typically an inch. And so in another scenario, if you had a screw that just had a traditional screw head, instead of having 2 pi times L, you would have 2 pi times R, where R is the radius of the head of the screw. We're going to work on an example now where we calculate mechanical advantage of a screw. We are going to do an example for the mechanical advantage of a screw. Calculate the mechanical advantage of a screw with a head diameter of 1 centimeter and a pitch of 0.25 centimeters. Now, assuming the head diameter is directly proportional to the size of the screwdriver that would fit inside of that head, we know that mechanical advantage is going to be equal to, or I should say ideal mechanical advantage, is going to be equal to 2 pi r, the radius of our effort arm, or in this case, the radius of the head diameter over the pitch. Now we can also substitute this equation just to be diameter times pi over the pitch. So in this case, our ideal mechanical advantage of our screw is going to be equal to 1 pi over 0.25 inches. Or I apologize. Centimeters. And those cancel out. We will come to an ideal mechanical advantage of 4 pi for our screw in this problem.